Alright, here's that last video. At the tail end of it, we looked at symmetry with just the one point. So now we're going to expand that to graphs. You see here these 3 points that we're going to go through, 3 types of symmetry dealing with graphs. Look at number 1. With x-axis symmetry, your graph is going to look like a reflection through the x-axis. Again, your x-axis, the horizontal one, looks like a mirror. So whatever the graph is doing on top is going to look like a mirror image on the bottom. Sort of algebraically, for every point xy that's on your graph, also the point x comma negative y is also on your graph. Let me show you a quick little graphic about that. For x-axis symmetry, let's look at like a sideways parabola, I guess. Alright, and let's say this is the point xy. Alright, and with y-axis symmetry, you go straight through the x-axis, same distance on the other side, so this is the point x comma negative y, the opposite of y. It's about right there. Alright, so whatever point, you could have started with any point. I could have started with a point way over here if I wanted to, reflect it straight through. It's supposed to be symmetric, and it'll lie again on the same graph. Keep your x the same, but take the opposite y value. Alright, that is x-axis symmetry. Let's look at y-axis symmetry. Similar. The y-axis this time acts like a mirror, and your graph will be a reflection through that y-axis. Here, for every point xy that lies on the graph, negative x and y is also on the graph, or the opposite of x, I should say. Let's look at a quick graphic of that. Let's look at an upside down absolute value function. That's lit up a little. This has y-axis symmetry, because if you look, this left-hand side and the right-hand side, it's like a mirror image of each other. Let's pick this particular point. Let's call this xy. Alright, if I reflect it straight through the y-axis, go the same distance on the other point, on the other side, I'm going to land on my graph, and this is actually the point negative xy, or the opposite of x. Alright, you keep the same y value this time. We're on the same y level, but the x's have changed. Whatever x this was, this is the opposite of that x. Alright, that's y-axis symmetry. Well, let's look at origin. Again, the graph is reflected straight through the origin. The origin's one point, so that looks a little different. Here, for every point xy that's on the graph, the opposite of x and the opposite of y is going to be on the graph. Let's look at sort of a cubic that's symmetric. Yikes, that's supposed to be symmetric. And let's pick an xy over here. Alright, xy. If I reflect this straight through the origin, go the same distance on the other side, this point is also on the graph. That is the opposite x value and the opposite y value. Right, here's my x, y I started with. If I take this opposite x, which is here, the opposite y, which is there, I will also lie on my graph. Alright, so those are the sort of 3 kinds of symmetry. Let's scroll down a bit. And these are actually the tests for symmetry. They're also in a gray box in your book on page 162, but here I've sort of paraphrased what they have in the book. For x-axis symmetry, what you do, they've got to give you an equation, first of all, with x's and y's in it. What you do, for x-axis symmetry test, replace your y with the opposite of y, and then simplify. Like if that y is raised to an exponent or something, go ahead and raise the opposite of y to an exponent. Or if it's added or subtracted to or from something, multiplied by something, go ahead and simplify. After you simplified, if you get an equivalent equation, then the original graph of my original equation has x-axis symmetry. The test for x-axis symmetry is to replace y with negative y. It's the opposite one. Alright, for y-axis symmetry, you replace x with negative x and simplify. If you come up with an equivalent equation, then yes, it has y-axis symmetry. These tests are pretty easy to remember because it's always just replacing the opposite variable and then simplifying. Now for origin, yeah, we're going to replace both y with negative y and x with negative x, then simplify. Alright, let's try actually an example of those. Here we're also going to find intercepts and we're going to test for symmetry. There's sort of a lot of writing in this. It's not difficult, but it is quite algebra intensive. So let's start with this part A, and I actually have this continued on the next page as well for part B. Find the intercepts and test for symmetry. For part A, you can see the equation is 4x squared plus y squared is equal to 0. Let's find those intercepts first. To find an x-intercept, we let y equals 0. That's at equals. Alright, so I'll have 4x squared plus the y squared again. That'll be 0 is equal to 4. Let's divide by 4 to get the x squared by itself using the square root property. You get two x-intercepts. One is 1, the other one is negative 1. Remember when you're using that square root method that you have to have plus minus once you get two answers. Alright, let's try the y-intercept. Let's let x equal 0. So if I plug 0 in for x, this whole term will go away to 0. I'll have y squared equals 4, in which case y is plus minus 2, so I have two y-intercepts. One's at 2, one's at negative 2. Alright, found those intercepts. What we are going to do is actually do those tests for symmetry. I will do them over here. Don't pay attention to this for now. I'll do B on the next page, so I'll have a little more room. This was a test for symmetry for part A. And actually those were, that wasn't a test for symmetry. These were the intercepts I found first. So now I'm going to test my symmetry over here. Alright, let's test x-axis symmetry. For x-axis symmetry, what you do is replace y with negative y. When you plug it in, put it in parentheses because we're going to have to simplify it. So I've got 4x squared. If you square a negative y, it's still y squared. Is this equivalent to what I started with? Yes, it is. So this does have x-axis symmetry. Alright, that's your test. We just did the test. We did it algebraically. We showed our work. For x-axis symmetry, replace y with negative y and simplify. Let's try y-axis. For the y-axis symmetry, you replace x this time with negative x and simplify. When you square negative x, you will get x squared. Yes, this also has y-axis symmetry. Alright, and let's check origin then. We would assume it has origin symmetry, but let's check it out. For origin, I know I'm coming up on almost 10 minutes, so I'll cut it off and then I'll do part B in the last video. For origin symmetry, let's replace both x with negative x and y with negative y, squaring both of those. So I'll still end up with 4x squared plus y squared is equal to 4. Yes, it has all three types of symmetry. Alright, yeah, again, a lot of algebra that you have to do here, but it's not too bad. Keep your tests straight. For x-axis symmetry, replace the y with negative y. For y-axis, replace the x with negative x, and for origin, you replace both. Alright, I'll finish this out. I'll do part B in the next video.